Well, hi, good morning. Thanks so much for joining me in my shop here for another day of messing around and experimenting with this radio. The last video, which I just posted, I forgot to post it, for crying out loud, so I just posted it now. I explored let me put it this way. This is the mixer tube, and so I kind of explored the input side of the mixer tube a little bit. Today I want to explore the output side and mess around with this radio, do a few experiments, and poke around, see what shows up. Well, I know it's showing up already. Look at this. Look what's showing up already. Peanut, you want to go back out? Okay. Weather here has been really very, very good. For November, it should be freezing when I wake up and maybe 10 degrees, at the peak of the day, but in fact it was 12 today when I woke up, and it's going to get up close to 20, 21 today. And so it's been for the last while. Unusually warm weather here. Very nice, and that's why he wants to go outside. I better let him out. I better stop. I gotta stop already. Okay, such distractions this morning. So we're going to start with the radio operating in essentially normal state. Then I'm going to attach this capacitor to the grid, the signal grid or the antenna grid of the 12 SA7 mixer tube. It's pin number 3 right here, has a green wire coming to it. A lot of these radios, I think I mentioned, they like to use green for grid. Maybe that's why. G for G, green for grid. So radio's operating. What happens when I put this on this grid? Does it go wild? I don't want to be touching this. It's kind of a long wire here. Let me just touch it for now. Volume. Okay, I can't let go. It's going to fall on my hand here. There's really no voltage here. It's not really a safety issue, but so my fingers are there. I'm a capacitor plate now. There we go. Okay, so it dulled down the radio a little bit. Exactly why? Don't know. Now, this is the antenna lead to my SDR. What happens if I hook this up here? Right, it's a grid, there's really not much voltage there. Things got pretty quiet on the radio. So obviously taking this approach really affects the radio. If turned up, it's still there. Maybe it's just draining the signal down, not shifting things too much. Let's see if my SDR survive that. Okay, I'm going to start it up here. And it's still working. Very good. Okay, now let me tune the radio and just watch what happens first of all. Okay, so you can see the local oscillator. It's very, very apparent. it's really apparent. Turn up the radio a little higher. If I tune down in the area of the station, I don't think we're going to pick any stations up. But there's a lot of stuff there on the SDR. Where's all that coming from? That's me tuning there. Well, you can see that I'm tuning it by the way the local oscillator is moving back and forth. But we're not going to pick any signals up like this. What we really need to look at, though, is what's happening right around 460. I think on the last video, I mentioned 455, force of habit. In this radio, the IF is 460. So why don't we, put your eyes down around the 460 mark, and there's something interesting going on there. Very good. Okay, you see things going one way and then going the other. Wonderful. I'm going to zoom the SDR right in on that. Ignore the rest. So the area I'm talking about is right in here, in case you didn't spot it. This is 460 right here. Watch what happens as I tune the radio back and forth. There's some stuff marching along in there. Okay, so I'm gonna expand that area. I'm gonna zoom in on it here. Now, tune the radio again. Tuning in one direction. Now tune back the other way. Let me mark where 460 is. 460 is right here. I'll put the red line there so we can keep our eye on it. So that's the IF frequency. So anything at that frequency, and of course surrounding it a little bit, should come out of the speaker. Let's see if something crosses there, if we can hear something. So although I can't interpret this in any kind of detail, I think what we're seeing is the action coming out of the mixer. The many signals. Anything that's a fair ways away from 460 will never hear it coming out of the speaker, and some of these may not be modulated. So even though I've got something sitting there at 460, they don't hear much. There's something stronger. So it's like a complicated mess. I think I mentioned the junk coming out of these tubes. Now, this is on, did I say this is the grid? This isn't the grid, this is the plate. That's what I was aiming for. Did I make a mistake here already? I don't want to be on the grid. Okay, hang on a sec. Let's just check. I'm going to check quickly in my book. 12 SA7. What did I do here? 12 SA7. Plate is on pin 3. I'm connected to 1, 2, 3. 3 has a green wire coming to it. And I said something about, that's where I got confused. I saw the green wire and started thinking grid. Thinking two things at once. We're on the plate of this tube. Is that absolutely for sure? That absolutely for sure. Let's do this. Now I've only got one lead connected going to the SDR, and that's again just to reduce the risk to my SDR. I could put this on the chassis. This is the ground to the SDR antenna input, or I could put it on the B-. It would make a big difference, and I don't want to do that. I think that would potentially put my SDR at risk, particularly if somehow I'm clued out about exactly what I'm doing here. This is the lead to my voltmeter here. We're going to check and just see what the voltage is on that. I'm going to clip this to the B-. Now this may cause the radio's operation to change a lot. This is way up. Way up. Oh no, this is way up, way up, way up. No, a little bit, but not a lot. Okay. Seems a little different. Let's go take a look at the farm. Well, make the voltage measurement. Plus 150, 75 would be straight up on this meter. Yeah, there we are. 65 volts. I'm running the radio with 105 this morning. It's not quite full voltage. Okay, so that rule about the green wire. Let's look at the SDR again. Okay, I'm going to take the ground wire. Let me turn it down. I'm going to take the ground wire for the meter off. You saw nothing change. Back on. Leave it on for now. Tuning. With the same stuff going on. There's quite a pattern to that stuff, right? Looks like there's things on here. As soon as I stop moving it, I just lose track of everything here. So there's an interesting gap here. Let's just take a look at the gap between here and here. 400, no, it's not much at all. 35 kilohertz. I don't know what that would mean. 35 kilohertz. I don't know. Looking for any hint at all. I'm looking for any insight I can gather from any of these observations to turn the light on in my head. Because it's pretty dark in there right now. Okay, since we can't pick up a station apparently, I'll try once again. Oh, I'm tuning it with the volume control. That's not going to work well. Here we go. Okay, so there should be a station right in here. It's not going to work with that clip on there. We really disturb the radio too much here, the way I'm doing this. So, what we could do is we could feed in a signal generator signal into the radio antenna, bring it into play, and see what happens. Okay, so if you're wondering what the real reason is for me doing this kind of stuff, I just find it a lot of fun. That's why I do this stuff. This is the output from my signal generator. I'm just going to hook one lead again, leave the ground off, although I do have a ground on the radio here now. Same ground. Just going to hook this up to the antenna through the connector here. Oh, we got to have the SDR up. In fact, I'm going to stop. I'm going to put the SDR on the same screen. Here, do the dual screen thing. Okay, here we are. So watch what I'm doing and what's happening on the screen at the same time. And I'll put the red line on the SDR up here is still at 460. And just keep your eye on the center of the IF band. Take this lead here. Fairly strong signal. This is actually, I'm going to dial this down to 460 because it's almost there now. So the signal generator is putting out the IF frequency. Why not? Got to start somewhere. Go on the antenna. Okay. So we hear something. We hear a couple things. We hear a shrill sound, and in the background you can hear a tone, a lower tone, 400 hertz tone that's coming from the signal generator. I'm going to guess the shrill sound is because this thing is sitting here. And isn't this the same shrill sound that I heard yesterday? So I'm going to force the signal generator right on top of this. I think I can just watch it. Can I not? I gotta move things here. It's probably a better view anyway for you. Right on top. Turn it up. Barely hear the 400. That's going from 400 to 1000. It's all garbled up, but it's in there. The rate is essentially not, because I'm not sending 460 anymore, it's not much off. 457. Oops. You can't see that. You can't read it anyway. 457. It's very close to the 460. If I boost this, so here's some pitches changing too, and that's because this is probably drifting ever so slightly. Let me try this again. I think it's drifting just a wee bit. Okay. What are we trying to do here now? Okay, so the radio, is it operating well enough to continue this experiment, or have I kind of killed it with this thing here? What would the experiment be? Well, we've actually done one already. We've already done the situation with let me turn this upwards. Okay, you hear that sound? Obviously you hear it. That's the difference frequency, audio frequency, that's being detected at the detector. Because this signal is making out, it's close enough to 460, it's making it to the detector. The detector is rectifying it, the audio signal is being recovered, and what you've got there is two signals separated a little bit, and you're hearing the difference frequency. So as I pull them apart, you begin to hear it going up. And the other way, do the same thing, up. It's fading out because I'm getting farther out of the range of the IF. So when you're tuning a radio, I better not say that. I think I'm jumping too far. But you certainly hear sounds like that when you're tuning a radio. You hear two things. One is pitches going up and down, and the other one is pitches that come in. So if there was a real radio station there, let's put a real radio station there. What I'll do is I'll change this off the IF frequency. I'll put it onto a regular radio frequency, and we'll tune it in on the front here. Let me just put this up around 1 million. I like 1 million. Okay, we're tuned to about 1 million hertz. I'll set this to around 1 million also. Yeah. Come on. You can do it. You can do it. Around here. So that large signal you see now is the, let's call this the radio station. So right at the moment we have a radio station operating at, well, we can't see it on the SDR. The SDR is focused just on the IF frequency, so I'm going to zoom this back in a little further. Okay, so the red line is remained at 460. This is the IF area. Now we can see the actual radio signal area. You can't see enough of it. So I'm going to slide this whole thing to the left. Like this. I'm going to reset the red line so we can keep an eye on it. 460. What am I going to learn doing this? I have no idea. I'm going to learn you can't do these experiments. So we're marking again the center of the IF frequency here. And this is the regular radio band here. And one of those lines is in fact this signal generator. If I move this, we should see it. There it is. Okay, so if I set this signal, you can see there's something happening down around about 500. If I move this to the 1 million mark, right on. I'm watching the SDR while I do this. Okay, SDR says that's 1 million. And what does my signal generator say? It also says it's 1 million. Okay. Just keeping myself honest here. Trying to catch stupid mistakes while I'm doing this. Some of them anyway. The whole thing's a stupid mistake, really. Okay. Now, this signal's coming in the radio, reaching the mixer tube. The mixer tube is presenting, let's just make it simple, the local oscillator frequency and this frequency into the mixer tube. And because the sound, where's the sound? Where's the sound? Oh, I don't know that this is tuned exactly right. That's not right. We should be hearing, I'm going to put this to 1,000 hertz here. Oh. Maybe doing this at 1 million isn't so good an idea. I can see, let me just wiggle this a little bit. Okay, so I'm just marking the signal generator frequency. So you can see the signal generator frequency is here, and there's another one right here. This is a noise signal or something in my shop. It's 9 kilohertz away. 9 is pretty hard to hear, especially out of a little speaker like that. We look down here now, and this is all crunched together. So we look at 460. 460 is right there. There's not much there. Just this big thing. Tune the radio. Now, what's changing is the local oscillator and the mixing product. The difference frequency is changing. And that's what that thing you see. You see the rate at 500 now? If I bring it down, it goes through 460. We should hear it. There it goes. Why the pitch? Why the varying pitch? Good question. Well, the only way it's possible is right. That's the answer to that question. When I'm doing this, there's just too much to think about while you're making these observations. I find I can't sort my thoughts out all that well. Probably a lack of coffee. You're doing it too. Let's do this. Keep your eye on this thing. That's a mixing product. How far up the scale would it go? Oh, wow! I mean, it's way up in the radio band now. That's kind of weird. Okay, so let's. Well, what it shows you is there isn't much suppression of the output products coming from the mixer. Is that what I'm seeing? Okay, let's do this crazy thing here. Is that signal receivable? Now, I don't know if I can pick it out of the air here. I'm going to try it with this radio. So we will that's around 600. So I'm going to go to 600. Tune the radio. 610. It's picking up the station. Now, wait a minute. So I think there's. Okay, so I'll put this at 600. 590 is the sports station. I'm going to vary this. Move that thing we see on the SDR, see if we're moving it through this radio. Plus this radio's got to be close here. This is the FM antenna. AM antenna is built inside here. Oh, there we are. Getting close to this wire. So what I'm demonstrating here is mixer tube is mixing the signal from here and the local oscillator, and the way the radio is tuned, the result is way outside of the IF band. It's right up in the AM broadcast band at 600. And it's strong enough floating around here, I can pick it up with another radio to prove it's real. It's not an artifact of what I'm doing. So I've learned something here. In my mind, coming out of the mixer tube is a small range of frequencies. This is what was in my mind. A small range of frequencies right close to the IF frequency. You know, 10 kilohertz either side, maybe a little more. But what it looks like is the whole shebang's coming out, strong enough to be seen. Now, this is a strong signal I'm feeding in here. It's a pretty strong signal on the antenna. In fact, this is, boy, you need a really good antenna to produce this kind of signal on it. Let me just check that with the calibration move here. Yeah, I don't think that made much difference. It just reduced the output a little bit. But when that is happening to this radio is tuned up around 1 million. Isn't it? I got it right, yeah. So this radio cannot hear the 500. It's not 600 rather. It's not coming around and going through again. What if I try to push this all the way up to where it's tuned? How would I do that? We'll just keep going here with this. And we'll just keep watching how far up I can get. The local oscillator, watch the SDR, what's wiggling? Local oscillator is not visible there. Where is it? So there's another strange phenomenon going on. No, it's not a strange phenomenon. So if we look around 1 million, this is what I was trying to do yesterday. Didn't have much success. That was seeing the front end tuning peak. You look around 1 million, and don't look at the peaks, the little peaks, but look kind of lower down here. Look down in this area, and you'll see that there's a response curve, in fact, going through. Every time it strikes one of these guys, they grow a lot. So I'll tune the radio. Can you see it? It's getting up around 1.1 here. See it at 1.1? Maybe the faster I move it, the easier it is to see. When it passes 1 million, you can see on the waterfall display, the signal's strong enough to light up the waterfall display as I go past the 1 million. That's because there is a 1 million signal there from the signal generator. Yeah, I'm not going to try to explain that just every time I've done this, I just get overwhelmed with the amount of stuff. I mean, good thing the radio can only hear what's happening at 460. All kinds of stuff happening down there. I'm looking between 400 and 500 kilohertz, and there's just piles of stuff going on. Piles and piles of it. And a big whopper coming in. We hear it come out of the speaker when it hits the 460. And I've tuned the radio to 9, what would be 9, well, just below 1 million. Maybe the dial's off a bit still. Yeah, my head is overflowing, but this is good. I like to do these things, and then the rest of the day I sort of periodically think back on what I did. And sometimes the light comes on then. Not usually. Okay, but we want to see the local oscillator. So I'm gonna move this whole, I'm gonna shrink this a little bit here. I'm gonna click here. And you see the entire band here. There's the local oscillator. It was just off the screen before. You have the local oscillator, and we also have the signal I'm putting in, which isn't very visible anymore. Let me move it. There it is, right around 1 million. So when I look at I can use my finger, but you can't see it. When I look at right in this area, where I'm moving the input signal around, there is another signal right beside it there. This time when I move the signal generator right on top of it, it doesn't get rid of that tone we can hear. It's very faint. The tone we hear, the pitch goes to 0. You can call that a beat frequency. That would be a good name for that. Goes to 0 right there. This says 1004 now. Yeah, what's happening? I forgot what my aim was. Oh yeah, I was going to try to drive that signal that was around 600. Is it still there? I've lost complete control. So let's do this for fun, okay? I've lost control, so I'm on to something else. I'm just going to move this way up and down the band and just see if there's any other times where we hear it come out of the speaker. The local oscillator is sitting at basically 1450 roughly right now. That would make sense, wouldn't it? 1460 would make more sense because I'm tuned here to 1,000,000. I want 1,000,000. Tune that back in. So I've stopped here because when I look at the SDR and the 460 is marked here, the signal's right on the 460. And I'm sure there's another signal just off to the side here. What if I short out the what if I short out the antenna? Yeah, I can do it easily just by connecting this to the chassis or to the B minus. In this case, I think to the chassis. Oh, that would be a ground in two places. That would be a ground on either side. Okay, we'll try it quick. Hey, that's an official shop technique. Nothing bad happening. What's happening on the screen? It didn't drain anything out. I was hoping it would knock the noise down because to some degree I'm shorting the antenna out here. So I thought anyway. Of course, I'm on the antenna. I'm not really. I'm isolated from the antenna by a resistor and a capacitor, or resistor anyway. What I'd like to do is kill all the noise and have just two beautiful signals there, a signal generator and a local oscillator, nothing else. How could I do that? Short out the antenna and feed the signal generator in a little further into the radio. Feed the signal in on the other side of the resistor. Okay. Now there is a capacitor involved with this coming from my signal generator. It's hidden in this little box here. So there is a DC protection on my signal generator. And I don't think there's any significant voltage here, or could there be? This will protect it anyway. Look, it's a big AC voltage. So nervous I am doing this stuff. Good luck. Look with a voltmeter. Got a voltmeter right here. Look with a voltmeter. Okay, just flip it to AC for a moment. This is now reading between the B minus. There's nothing there. Oh. Well, this is just to get a calibrated result. There's nothing there. Nothing there. Somehow I don't think this will make any difference. Okay, flipper's on. I'm going to skip past the resistor. Did make a difference. So there's a whopper of a signal at 460 now. I guess a good question from a radio repair point of view is you hear the interfering squeal that's varying in frequency. How do you get rid of that? Is there something wrong in the radio that's making this worse than it should be? I mean, if I tried to pick up any station at 1,000,000, if there was a station there at 1,000,000, this would come along with it, this shrill sound. I could drive up the AVC. Drive up the AVC and desensitize the radio by jamming a heavier signal in from here. Okay, I wasn't watching the SDR, I was watching it. So I don't see any variation in all these other signals, all this stuff that's up here. I thought that would go down. You know what that means? I think that means the SDR is picking it up just out of space. Let me turn off the radio and see if that's done. Oh, it even gets worse. Oh, there's something to even stop and think about. Okay, so I think I need to put the SDR ground on. Where? B- would be the best place. How big is the signal here? Well, we can try, it's a high frequency signal. I don't know if my voltmeter is going to reveal it. I will try. You can watch here. I'm going to just... So my voltmeter is hidden behind those wires there. So it's set to AC. This is not going to work. This can't work. You jumped up for a moment there. 65 volts on the other side of that capacitor. Nothing on the 65 here because I'm on the plate. Oh boy, going around in circles, filling my head with nonsense. Done this quite a few times now, and yeah, I keep waiting for the fog to clear away, but it doesn't. In fact, the more I do this, the more foggy it all becomes. I think I need to inject something here. I think I need to inject some coffee into me. I just stop for a little bit and try to get my feet back on the ground here. I sort of lost track of what I'm even trying to do. I am just kind of running around, snooping around, poking around, because, maybe I'll make a discovery. Discovery for me. Okay, a couple gulps of coffee seem to have done the trick. So what I'm trying to do today is basically put two signals into the mixer. One be the local oscillator, and the other one is my bench oscillator. Fool around with the bench oscillator frequency and then see the products coming out of the mixer. The problem I'm having is I have too many signals showing up on the SDR, some of which are not coming from the radio. They're just being picked up by the SDR. And just so many signals on the screen, I'm going cross-eyed trying to sort it out. Now let's look at the schematic here. I have this up just to talk about the tank circuit here. So the output of this is where I've got my SDR connected right to this, lying through a capacitor. So I'm watching what's coming out of this tube. And what's going into it is the antenna signal onto grid 3 and the local oscillator onto grid 1. And that should cause a mixing inside the tube and get products. So out of here would come, I think, 4 signals. The antenna signal, the local oscillator signal, the difference signal, and the sum signal. All those are presented here. Now what's going on here? So this is a tank circuit. At resonance, this becomes high impedance. Off resonance, this can look like a short circuit, or at least a lower impedance circuit. There's a certain roll-off to these resonances. I can't remember what it was, 3 dB per decade, I can't remember now. Something anyway. If you move too far away from the tuning of this, with these frequencies up here, they will really experience a short here, or very low impedance, and they will be quelled. They will be weakened. I mean, you just think of it, if this wire were hooked up to ground, what would you hear on it? You hear nothing. between this wire and ground. So I'm pointing to this as ground. I'm not sure that's really the ground. That's actually it's not the ground. But don't not to worry about it. The idea is still valid. If is this not the ground? This is the ground. B minus. I'm just so turned around today. Holy smokes. So even if I do have 4 products being produced by the mixing effect, one of those products is the sum of the 2 inputs. So I'm putting in, say, a local oscillator at 1500 and putting in my signal generator signal at 1,000,000. That's 25. That's 2.5 million is one of is the high product or the sum product. That's way far away from 460. Way far away. So it would probably be attenuated dramatically here, which is kind of what you want, because who needs it? All you really want is the 460, which is going to be experiencing a high impedance here. Any 460 frequency will experience a high impedance. So could you even see that second? Well, if it's there, we might be able to pick it up with another radio again. Why don't we try that? Just see if I can somehow hear it on another radio. So we'll pick some lower frequencies. I'll tune the radio down so the local oscillator is around 1,000,000, just to confuse things. So that would mean the radio needs to be tuned to a frequency 460 below that, which would be 540. So tune the radio to 540. The local oscillator should be, well, we can see it on the SDR anyway. They'll put the local oscillator at 1,000,000. Bring in the signal generator at 500. The 2 combined is 1500. That's within the range of a radio. Let's see if we can hear it. Well, that sounds like fun. Okay, so first I'll tune the radio down to, I've already forgotten what I just said. But we want to get the local oscillator around 1,000,000. It's right here on the screen, so it's easy for me to do it. Okay, so we're at 1,000,000. Now, hey, notice something showed up at 2,000,000? That's pretty interesting. So the local oscillator, of course, has harmonics, and 2,000,000 is one of them. Now, the local oscillator is not modulated, so hearing that on another radio is pretty tough. It would be tough. You might know it exists because your radio will quiet. Let's try it. Let's try it, because it's pretty strong. Okay, so we gotta go shortwave here, 2,000,000. Shortwave 2,000,000. $2,000 kilohertz, that's 2,000,000. Whoops, what happened? Bump the volume. Tune the radio and I'll cause the radio's local oscillator harmonic to move around. Wow. Okay, well, there you are, right there. Bingo. So there's a whopper 2,000,000 signal coming out of here. It's a whopper. Did I bump the volume there? I did. Let me hold it way over here. Oh, you hear this on the other side of my house. Interesting. Bit of a hum in there. I don't know what that's from. So many things. Okay, reminded that there's quite a harmonic, and there's probably a 3,000,000 harmonic. There's probably a 3,000,000. There it is right there. Would it be a 10,000,000? The answer is yes. It's like an accordion, you know, as you tune the radio down, the harmonics are more closely spaced. You tune the radio up, the harmonics are leaping out. Okay. Now, what I wanted to do now was bring in the signal generator somewhere around 500, like 500. Let's turn the radio up just for fun, in case we miss something exciting. Okay, that's going to the IF. Okay, we're just up above the IF now. 500. So we have a 500 and a 1000. There should be a 1500. Maybe. Let's see. 1500. 1500. You can move either one of these frequencies and it should sweep across here. I'll tune the radio. There it is. Very weak. Well, can you see that on the SDR? So I'm looking around 1500 on the SDR here. Is there something moving around there? There is something. Okay, so the something, I am going to turn this until the something is at 1600. 1600. Okay, that little ding on my phone means somebody's in my driveway. Okay, so there's something maybe at 1600. Can we hear that? What's happening there? 1600. Tune the radio. Yep. Nope. Not hearing that. So what? So let me go looking at the SDR again. 1600. Anybody following this? I'm barely following this. 1600. Okay, putting the thing at 1600. Oh, there's a huge noise signal right at 1600. When I get to 1600, it's buried in it. Okay, so I'm gonna go up above 1600 in this little valley here. I'm talking about right here, right here. So that's now 1615. Okay, let's go 1615. Something there? Wait a minute, I did 1650. That's not 16. 1615, right. Not going to do it. Okay, don't know how to interpret that. Could be it's just weak. Look at how weak it is compared to all those noise signals. I mean, it's way down there. I can make this stronger. If I input more signal from the signal generator, I should boost that thing. But at that point, I am whacking this radio a lot. Okay, let's whack it here. Here we go. Eyes on the... So the 16 thing just leaped up. 16, 15, still there. Now can we hear it? Oh, I think so. Absolutely. In my listening post where I have all my shortwave radios, they all share the same antenna. And they haven't done anything fancy to isolate them. They're just all on the same antenna. And occasionally as I tune one radio, I'll hear something happen in the other radio. And I realize, oh, that's the local oscillator or something. But it could be a lot more than that. So Okay, I think I've worn myself out here with all this. I think I need to stop and think a little more about everything, and maybe a slightly better approach, some way to improve this. Remember, when I made this connection, it caused the radio to weaken a lot. So, and these signals that are all over the SDR, not coming from the radio. So that's another factor. Somehow I have to get rid of them. Radio's switched off now. I got rid of a fair bit. And if I go right on the B minus, about the same, of course, I think. Okay, radio, don't explode on this, please. Don't explode. I'm talking about my little guy. Well, that's what's happening here. Getting a much stronger signal into the front of the SDR. So what's happening? I need to put a much smaller capacitor here. Didn't I say something about I'd had enough of this? Smaller capacitor, because this is a fairly big one. I need a tiny guy. I need a tiny guy. Okay, I gotta set that up. Okay, so what I've done is I've soldered a small capacitor on here with short leads. This is a around a 300 picofarad capacitor. We connect here like this. Well, that looks pretty good. Is that my hand doing that? Okay, power it back on. Hopefully the local oscillator doesn't blast away in there. It'll still be pretty strong though. Nope. Wing. Wow. Now the reason the other signals have gone down is almost certainly because well, that was interesting. It's all interesting. That's a whopper of a signal being sent into my SDR, and the SDR has an AVC. It's calmed itself down. That's why those other signals have gone down. The SDR sensitivity has gone down. The local oscillator is still just a whopper on there. The local oscillator's getting on this wire either by just airborne activity, I don't know, or because of the modulated current flow going through the tube is passing the signal, the antenna grid. So you have a modulated current, modulated by the local oscillator, if you like, and it's causing the flow of current to do those things right there. And then that's got to be affecting the grid a little bit. That's why we're able to pick it up so strongly on the other grid. How's this going to help now? The radio's gone quiet. How come that? Why would that happen? Because maybe the way I had it set up before, I was feeding a lot of junk into the, from this thing. Not quite the result I expected. The local oscillator is still going at 500. See any sign of it? Not my local oscillator, the bench oscillator here. There it is. Now, two things popped up there when I did that. One of them is the actual signal from here at 500. Oh. So, okay, that's not quite. What are these? Why did this one show up? This is the 500 from my signal generator. So we got 500, and we got, this isn't at 1,000,000. How'd that happen? Changing components in there has caused this to set this at 1,000,000. Easy calculating. Now you see quite clearly, 500 plus 1,000,000 is 1,500. If you look closely, there's two signals here, and there's two here. How come there's two? Let me vary the signal generator over here a little bit and watch in the IF. Well, I've gone totally silent now. Let's turn the radio up. It is up. Can't hear a thing. But I have a much cleaner display here. Oh my gosh. Oh, right. These two signals we're looking at, they're not in the IF. They're around 500. The IF's down here. So until something gets down in this range, nothing will come out the speaker that we can hear. So the question would be, it's clear that this is the signal generator going down, reaching the IF. What's that thing that's going up? I would expect to only see this signal. Where's this one coming from? And this is like you almost think of it as a reflection on these going across. Is that true? We set this one, we'll set the signal generator to, let's get away from that thing. Oh! Wow! So the signal generator is up around 600. I know that from the frequency counter. And the other thing is at 400. Well, I was looking for things to think about today. Perhaps this is all clear to you. I would be amazed, but it could be. You may be way ahead of me in this game. And all this just to try to understand better what goes on inside and outside of the mixer tube, because I suspect a lot more goes on, and I have good reasons to suspect all that, while it could be all the books that were written in the 60s and 50s and all that stuff. Most of these radio repair books were written back then. The guys writing them never saw this stuff. Never had the equipment to see it. Yeah, they would have had spectrum analyzers, perhaps. That's a very, very expensive instrument. Guys writing books are usually in labs with a lot of stuff. Engineers designing these radios have labs, and they have stuff like spectrum analyzers. But whether they could even do what I'm doing, I don't know. If they did do what I'm doing, then they probably lost their minds and quit their jobs. Never designed a radio after that, because it was all too much. Yeah, I'm going to call it quits here, because it's getting late in the day. We turned our clocks back here yesterday, but it's still getting late in the morning, so I think I've seen enough. There's just all kinds of things here to think about and look at. Yeah. Okay, well, thanks a lot for watching, and hope you're finding this interesting. Probably finding it just as confusing as me. Maybe by tomorrow some of the fog will be gone. I'll be able to do a little better job of this. So, thanks a lot. See ya.